Okay, welcome back. This is MAT127 on Blackboard. This will be video 4B. Again, I'm Joe Cooper-Sannon, and let's get started. Main point of this video is we're going to start to summarize quantitative variables. I have an example here on the slide. A few semesters ago, students in MAT127 took a sample of books in the library, and one of the variables they looked at was number of pages. So over 100 students, here's a histogram of that data, and we want to start to summarize. Back a few lessons ago, we discussed the shape, so this is certainly unimodal, and I would probably say skewed right, with at least one high outlier up there. What we want to zero in on is how can I describe the center of this distribution. We know the two choices. The two choices are going to be the mean and median, and so we will get going with that. All right, summarizing quantitative variables, we're going to move to calculating the summary statistics. Always start with histogram. We're looking to see if the shape is roughly symmetric or skewed. Okay, we've got to hit the 4 points when describing a quantitative variable. We certainly have to mention shape. So skewed or symmetric, and how many peaks do we have? Certainly have to mention the center. We're going to get into calculating statistics to describe the spread, and we always want to give details about any unusual features, whether or not there are any or there aren't. Okay. So 4 points. Main point of this lesson is we're going to look at the center. Okay. So two main options, mean and median. It all depends on the shape of the distribution. At times the mean is the best, and at other times the median will be the best. So we have two main options for a single number that describes the center. One is the mean, the other is the median. Okay. And if we look at the library data, this is pretty severely skewed to the right. And you can see I have a mean. If I calculate the mean, it's 402.096. If I calculate the median, it's 353. These numbers are very, very different. Okay? And so in one case, the median will be a better measure of center. In other cases, the mean will. And you can see we don't want to really report both because they are very different. Okay? One does the job better than the other. If I have symmetric data, we're going to pick the mean. Okay. And the main question is, why do we pick the mean? Okay. There's a couple good features about the mean. Number one, when we calculate the mean, and we've calculated means before, if you go bowling, you bowl 3 games, calculate the mean, add up your 3 scores, divide it by 3. The mean uses every data point. Okay, that's a good feature. If we collect a lot of data, we'd like to use every data point that we have. So number one, mean uses every data point. Number two, if I have symmetric data, I won't be in this situation. This is clearly not symmetric, but very skewed to the right. I have some outliers, possibly one, maybe these values here. These values will inflate the mean. So if I have large values, the mean is going to get pulled up towards the large outliers. You can see here in the library data set, the mean is 402 pages. It's almost 50 pages bigger than the median. So those huge books inflating the mean. Symmetric data, we won't have that problem. So number one, we'll use every data point, and number two, outliers on one side. So for example here, skewed to the right. Outliers on one side won't be an issue. With symmetric data, this won't happen. With skewed data, it will. You can see the effect. Okay, so we look to the shape. If it's symmetric, we'll pick the mean. So obviously the answer on the next slide is if we have skewed data, we'll pick the median. Library data, surely the median is a better measure of center. 353 is describing the center much better than the 402. This is distorted by the outliers. Why do I pick the median? With skewed data, outliers are typically present on one side, right? Skewed data, you're going to have a long tail. And those outliers will affect the mean. I'll even say outliers will distort the mean. Maybe an extreme case here with this mean almost 50 pages larger than the median, but it will always happen. So if the data is skewed, we'll pick the median as the best measure of center. All right, so moving forward here. New example. A couple years ago I was in a bowling league. I recorded all my bowling scores as a statistician might happen to do. Here's a histogram of my bowling scores. The data could be characterized as skewed, right? If I tried to draw in a smooth curve here, there's definitely a little bit of a tail heading out to the right. We would pick the median. If we had to pick one measure of center, we would pick the median here. And the question A here says, which measure of center will be higher, mean or median, and why? With skewed right data, median is going to be lower, mean is going to be higher. So this distribution is skewed to the right. Which will be higher? Mean will be higher. Now it'd be impossible to figure out exactly what the mean and median is with the data here. I did calculate it using StatCrunch, and I'll give you those two numbers so you can see the difference. For this data set, my mean bowling, or my average bowling score that year was a 188.05, which sounds a little bit better than my median. Median bowling score that year was 182. And so when I'm talking with my friends, clearly I'll tell them my mean is 188. Sounds better than the 182, but this is probably a more realistic picture of the center of my distribution of bowling scores. All right, I think there's a part B to this one. And same data set, interpret the value of the median with a sentence. Okay, so what is this median? We talked about it in earlier lessons when we were describing distributions. Half of the time, the median was 182, so half of Hoops games are 182 and below. Half of my games are 182 and above. All right, half of Hoops games are 182 and below. Half are above. So it's sort of, if I organize my scores worst up to my best games, where would 182 fall here? This is 150, 60, 70, 80. So if I put a line here, there's 182 on this histogram. Half of the blue area is here to the left. Half of the blue area is to the right. That's what the median does. It chops at 50-50. Okay? And you can see visually that half the time I'm from 182 and below. If I put a line at my 188.05 mean, it wouldn't be doing this job. We don't want to confuse what the mean does compared to the median. All right. So moving forward, I'm sure most of us have calculated the mean by hand. Let's get the symbols and formulas up here on the board, and then we'll do it for a new example, a little bit smaller data sets. Okay, in this class, we're using y bar as the symbol. It's just a letter y with a bar over it. And we do know how to calculate means. I'll put it in words first. All you do is add up all your data values. And you divide it by the number of data values. go bowling, you bowl your 3 games, add up your 3 scores, divide by 3, and you've got your average bowling score. Okay? This is a math class. I'll give you the symbols. Again, it's a fraction. This is the summation symbol. If you haven't seen it before, it's a capital letter sigma, but this just says to add them up. And in Math 127, we do typically use the letter y. So all this says is add up your y variable, or add up all of your y values, and we'll use a lowercase n for the number of data values. So probably the easiest formula of the whole course, but there it is. Add up your y's, divide by n. All right, advance the slide. New example to finish out this video. An article reported single leg power measurements. So I have 14 elite endurance cyclists, and it was guys in the example that I found. I don't know what the units are for this. Some sort of power measurement. Okay, it says to calculate the mean by hand. We'll get right to it. Symbols y bar. I'm not going to write all 14 numbers down, but 244 plus. I'm adding them up. 191 plus. I'm sort of bored with this, so I'll do the dot, dot, dot. Add them up. I get down to the last one, and I get to 200. Okay. How many do we have? 1, 2, 3, 4. 14 of them. Divide by 14, and it is as easy as that. All right. I've got the sum. I'll tell you that they do add up. It's 2696. Up top, divided by 14. And if we put equals, it's about 192.57. And there it is. Simple as that. That's your average, or we would call it the mean in a statistics class. All right. Advance the slide, moving on. Calculate the median by hand. There's some space in the notes. We'll write down the steps quickly how to do it. Step 1, calculating the median by hand. What we need to do is organize or sort the data smallest to largest. All right, sort data smallest to largest. If your data is not sorted, you have to sort it by hand. Now, one thing, between me and you, eventually StatCrunch, the software that we use in this class, will be calculating all of this stuff automatically. We do need to learn the ideas behind these statistics, so typically on the videos and in class, we'll do a few examples by hand. Step 1, sort the data, smallest to largest. One thing you have to think about, if you have an odd number of data values, one single value will be right in the middle. So, if you have Part 2, if you have an odd number of values, so count up your data values, then the median will be the one that falls right smack in the middle once they're sorted. Okay, number 2, if you have an odd number of values, the median is going to be the one that falls right in the middle. Okay, remember what the median does. The median is the value that chops the data, bottom half of the data up to the top half. Okay, so this is for odd. Last thing we need to think about, if I have an even number of data values, one of them won't fall right into the middle. And if that's the case, what we do is we take the 2 in the center and we just average them out. Okay, so we'll still have to sort. Let me make some space here. Okay, still sorting data smallest to largest. And switch over to the pen here. If we have an odd number of values, excuse me, if we have an even number of values, median will fall, not right in the middle, but we'll take the two values in the middle. So if we have an even number of values, take the mean of the two center values. A little bit wordy to write down, but once we get some data in front of us, it goes pretty quickly. All right, so let's do that. Cycling data, previous page, calculate the median by hand. First thing we'll need to do is sort it. I'm presuming we can do this at home, so I'm just going to fill these in rather quickly. The smallest value was 160, if you look back on the previous page. And going forward, I get a 174, 176, 180, 180, 183, 187. It's on the top. That's actually the bottom half of the data, right? It's 7 and 7. There's 14 total. Second row here, 191, 194, 200 even, 205, 211, 211, and powerhouse up there, 244. Okay, step one, sort the data. I have an even number of data values, so there's not going to be one that just falls right in the middle. Here's the bottom half of the data. About right there at my squiggly line is the middle. Here's the top half of the data. All I do is I average out the 187 and the 191. So calculate the median by hand. Median's easy. 187 plus 191. Pop it over 2, average it out, and about 189. And there's the median. Okay, pretty easy, pretty straightforward, as long as the data set's on the smaller side. With hundreds of numbers, we really would draw on technology to figure out medians and means. Okay. Question for us here: what would happen to the mean and median if the strong guy here, the guy with leg strength of 244, actually had leg strength of 205? So if he was a bit weaker, he'd be 205. I guess he'd squeeze in right here. These two would sort of shift over. And we don't have to calculate the median. We don't have to really do anything on the calculator. The middle position is still right here, right? This change doesn't affect the bottom half of the data, and it's certainly not affecting this. So when they're organized, smallest to largest, there's no change to the median, right? Median's still what it was. Median's still 187, 191, average them out. We did it on the previous slide. No change to the median. I guess you could almost, sort of looks like an outlier here, right? If the outlier sort of came closer to the rest of the data, no change to the median. The mean will change. Of course, we know the mean takes every data value, adds them up, divides by the total. So the mean, which was here, remember the symbols, we'll add up the y's and divide by 14 still. 160 plus plus plus. Get rid of the 244, add the 205 in there. I've got the total here on the sheet. It's now 2657. Still divide by 14. And the mean is now 189.79. I've forgotten what it used to be. Good thing I wrote it down. The original data set used to be was 192.57. Back now that I think about it. Okay? So you can see this one sort of large value compared to the rest. it did affect the mean. That value in there sort of inflated the mean by almost 3 units. Right? So we need to be aware of what's the shape of the distribution, and the mean or median, one of those will be the better measure of center. Okay. To wrap up, I think we've got one slide left here. And to summarize, why do we use the median if the data are skewed? The answer is the median is resistance to outliers. A couple high outliers, a couple low outliers, the median won't change. The median is that middle position, right? So just be aware, if you're looking at data that's typically skewed, salaries are typically skewed. Most people sort of make lower salaries, and there's a few people that make very high salaries. It's a skewed right distribution. Home values, net worths, those all are typically skewed right. Grades in college courses, maybe the opposite. Most students typically earn 90s, 80s, and 70s, and you'll have a few, not so hot grades, 20s and 30s. Those are typically skewed left. And a lot of times, because of that, we'll report the median rather than the mean. To wrap up, in Math 127, typically we're going to use StatCrunch. If we haven't already in class, we'll do it very soon. But when we learn the topics, when we learn the concepts, we want to demonstrate the ideas with the formulas. Do it by hand once or twice so that we can understand what these numbers mean. Okay? So thanks for watching, and see you next time.